Hey everybody, I am working on your videos now for lesson 5-5, and the title of this lesson is Indirect Proof and Inequalities in One Triangle. Now the good news is that that is on page 332 and we will be skipping the whole page. We are not going to do the indirect proofs right now, so you can just mark through. As you can see, I have marked through this paragraph in my book and all of this, including the bottom, example 1. And you can just leave this page behind and move on to page 333. And we will be starting at the top of page 333. If you will read along with me, your book says the positions of the longest and shortest sides of a triangle are related to the positions of the largest and smallest angles. This is going to be interesting. This is going to open up a new thought process for you with all those puzzle pieces that we talk about with geometry. So we're going to be looking at a couple of theorems that lead us further into this. And what I just read to you, again, explained indirectly that there is a relationship between the sides of a triangle and the angles of a triangle. So let's move forward by looking at this first theorem. This theorem does not have a name. This is one of those that is labeled by numbers and then abbreviated. If we were ever to need to use it in a proof, we could simply say this: in a triangle, the larger angle is opposite the longer side, and we could use those abbreviations like we have in the past. But let's read this theorem. It says, if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. Now, I think the order of their wording in that theorem is a little odd, so I'm going to put it into my own words for you. But what it's saying is that in a triangle, your longest side of the triangle is going to be opposite your largest angle of the triangle. And on the flip side of that, your shortest side of a triangle is going to be opposite your shortest angle of the triangle. I hope I said all that right. I'm going to repeat it just in case I didn't, because I think I could have mixed up a couple of words in there. So let me repeat it, and you make sure you grab hold of this second time around, just in case I didn't say it correctly the first time around. So in a triangle, your longest side is going to be opposite your largest angle. Your shortest side in a triangle is going to be opposite your smallest angle. Do you see that unique relationship? Let's look at a picture of this that I can draw. So if we have an obtuse triangle, for example, you can automatically tell that this is going to be the largest angle and it is opposite the longest side. You can also tell, let's think of a really tiny angled triangle. This tiny angle is going to be opposite the very shortest side of this triangle. So we're building understanding of that relationship. So they're saying that the converse of that is also true, that if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So this time we're focusing on the angles and we're saying, okay, wow, this is definitely the biggest angle in this triangle. So this is going to, its opposite side is going to have to be the longest side. Conversely, y in this triangle is the smallest angle. And so xz is going to have to be our shortest side. So that's a relationship that we will build on. We are going to skip the proof below it because it goes back and uses the indirect proofs from the page before. And we are going to look at example 2. All right, so I'm going to push my book out of the way a little bit, and we're going to be using my notebook some to do this. So just reviewing really quickly, in a triangle, and this is the abbreviation for those theorems, in a triangle, the larger angle is opposite the longer side. That's what we looked at. Larger angle right here is going to be opposite the longest side. And conversely, in a very small angled triangle, in this one, this is going to be our smallest angle, and it is going to be opposite the shortest side. So quick review, and now let's apply all of that by looking at some triangles. So this is from example 2 at the bottom of page 333, and this is triangle GHJ that I have drawn on my paper. And what the book is asking us to do is to write the angles of this triangle in order from smallest to largest. So therefore, we also have to look at our line segments or our sides of the triangle and see which one of them is smallest, and then work our way to largest. So we can look here and tell that side GJ is our shortest side. If this is in fact our shortest side, then the angle opposite is going to be our smallest angle. So angle H is going to be the first angle we write down because it is the smallest angle. Our next shortest side is 28.5. Therefore, the angle opposite it is going to be a little bigger than angle H, but smaller than angle G. So we're going to say angle J comes next from smallest to largest. And lastly, we can tell that JH is our longest side, so the angle opposite it has to be our largest angle. So in order from smallest to largest, these are angle H, angle J, and angle G. Okay, let's look at one using the converse. We're going to use our triangles here to name our sides from shortest to longest, but we don't have all the pieces of the puzzle. When I add 39 plus 54, I have to figure out what's missing to get to 180, and I'm pretty sure, not taking time to double check my math, that that is 87 degrees. Let me do that on paper really quickly right here. I am doing it off to the side, so y'all just bear with me for just a second. Yes, that is 180 degrees. So we can now order our sides based on what we know about these angles. Our smallest angle is angle L, so our smallest or shortest side is going to have to be side KM, or line segment KM. So remember, we're going shortest to longest this time. Our next smallest angle is going to be angle K. So our next side length is going to be LM. And lastly, our longest side is M. Therefore, our largest angle is M. Therefore, our longest side is going to be KL. All right, pretty easy on that. And let's look at just a couple more to cement this. This is probably going to be the longest video of today, and I will move through these quickly. So I am going to order my angles again from smallest to largest, basing that upon the sides. Here is our shortest side, so we know the angle B will be our smallest angle. Our next shortest side is CB, so we know that the angle opposite, which is A, is going to be the next smallest angle, and that the last or largest side of this triangle is AB, and the angle opposite is going to be the largest angle, and so we know that angle C is going to be last from smallest to largest. We would do the same thing here that we did in the last one where we did angles. We're missing a piece of the puzzle, so we say 90 plus 22 plus what equals 180, and in this case it's 68 degrees. And y'all bear with me again and let me just make sure I'm on the right path. 60, 70, 80, 90 plus 90, yes, we're good. So our smallest angle here is 22 degrees, so EF is going to be our shortest line segment. Our next smallest angle is E, so our next line segment length is going to be DF. And lastly, our largest angle is 90 degrees, that's angle F, and so our longest line segment is DE. What I want to point out to you and help you to realize here is that if you look at a triangle like DEF, I'm going to redraw it just to show you. This might help you to kind of understand what we're applying. This is your biggest angle, and because it's a big angle, the opening between the two sides is a big opening. That means there is a lot of space to fill to connect those two lines, and that is why, therefore, this is the longest side of the triangle. It would be even longer if we were to look at a triangle like I showed you earlier. This is a very open angle, well over 90 degrees. So it has spread these two sides far apart, meaning we've got to have an awfully long third side to fill in the gap. So that might help you understand that a little bit more. Conversely, if you look at this one, we've got a tiny angle. The sides are not spread very far apart, so it's only going to take a tiny side to connect them. All right, that's all for this almost 10-minute long video. Hopefully the next ones will be much shorter. I hope that helps get you off to a good start and you be ready for number 2.